Hello everyone, welcome to Unit Conversional Series Part 2. In this video, we are going to discuss questions on mode concept. I have already discussed unit conversions and important formulas on mode concept in my previous video. If you haven't watched it, please go and watch that video first, revise all the formulas and come to this video. Okay, and before your gate examination, just be confident, believe yourself. Actually, we humans have so much of potential. We can do anything and everything. But the problem with the human mind is we don't believe that we can do anything. Right? If you believe yourself that you can do anything and everything, you can definitely do. Okay? Karam karo, fal market se buy kar lena. All the best. Let's go to the video.
Hello everyone, welcome to Krish Chemistry. This video is regarding questions on mole concept. I have already discussed about the unit conversions and important formulas in the previous video. If you haven't watched that video yet, please go and watch that video first. Download all the formulas which I have given in the description. Revise all the formulas and come to this video. Okay, so let us start. Now these are the formulas I have given already in the previous video. You can check. Now the first question, 2 into 10 to the power of 18 molecules here, 2 into 10 to the power of 18 molecules, 2 into 10 to the power of 18 molecules of ammonia present in a vessel. Calculate number of moles of ammonia. Simple. Given number of molecules and asking to calculate the number of moles. Which formula you have to use? Simple. This second formula, number of moles equal to number of molecules by Avogadro number. This formula you have to use. Already you have one container here, right? You have one container here, or you have one vessel here. In this vessel, totally you have 2 into 10 to the power of 2 into 10 to the power of 18 number of ammonia molecules are there. Okay, so what is the number of moles? Simple. Number of moles equal to number of molecules by Avogadro number. Okay, so number of molecules 2 into 10 to the power of 18 by, for simple calculation, here Avogadro number I am taking as 6, actually 6.022 into 10 to the power of 23 per mole, right? But for simple calculation I am writing 6 into 10 to the power of 23 per mole. I can write like this. Okay, so if you calculate this, 2 3 ja, so 1 by 3, here 1 by 3 into 10 power 18 minus 23, 1 by 10 power 23 I can write as 10 power minus 23, 18 minus 23, 10 power minus 5, 10 power minus 5 mole per mole here in the denominator. If you take a numerator, mole. Then what is the value here? 1 by 3, 0.33 into 10 to the power of minus 5. How can you write this? 3.3 into 10 power minus 6. Okay, right? If you move to right, then you have to take minus, extra minus. If you move to left, you have to take extra plus. So 3.3 into 10 to the power of minus 6 moles. So this is number of moles. Okay, this is the answer. Okay, next question. How many hydrogen atoms, carbon atoms and oxygen atoms are present in 2.5 grams of maltose? Okay, here one compound given and asking to calculate number of atoms. Which formula you have to use? Again, this formula, AXBY, number of atoms equal to x into number of molecules, right? So this formula you have to use. How to do this question? Simple. First of all, I'm writing here number of hydrogen atoms. Okay, how many number of hydrogen atoms are there? Here 22. So 22 into number of molecules. Number of molecules. Number of molecules. In the same way, number of carbon atoms. How many number of carbon atoms? 12 into number of molecules. Number of oxygen atoms. 11 into number of molecules. Total number of atoms here in this molecule 45 into number of molecules. Then if you can find out number of molecules, then you can calculate this all, right? Then find out number of molecules. How can you find out? Given 2.5 grams mass, we know number of molecules equal to number of moles into Avogadro number. We have this formula, number of molecules equal to, because number of moles equal to number of molecules by Avogadro number. We have this formula. How can I write this? Number of molecules equal to number of moles into Avogadro number. I can write like this, right? Okay. Now this, first of all, I have to calculate number of moles. How can you calculate? Number of moles equal to weight by molecular weight, 2.5 grams by molecular weight of maltose, that is 342. 2.5 grams, 342 molecular weight, gram per mole. Gram get cancelled. Now what is the value of this? 0.0073 mole. So this is number of moles. How can you get the number of molecules into Na? Okay, this is the value of number of molecules. Simple. Now you have to calculate number of hydrogen atoms. 22 into number of molecules, 0.073 into Na. Carbon atoms, 12 into this value. Oxygen, 11 into this value. Total number 45. How can you get this 45? 12 plus 22 plus 11, 45. So 45 into this value. Okay, that's it. Third, which of the following contains large number of atoms? He's asking large number of atoms. Simple. For suppose I have the container, right? If in this vessel, if I have one water molecule, how many number of atoms? 3. In the same vessel, if I have two water molecules, how many number of atoms? 2 to 4 hydrogens, 2 oxygens, total 6. So if number of molecules are increasing, the number of atoms are also increasing. On increasing the number of molecules, atoms will also increase. Yes or no? Yes. Okay. So number of molecules increasing, atoms increasing. So if I calculate number of molecules, enough for me. Calculate number of molecules. How can you calculate? Simple. The first option, 2 grams of copper. Everywhere, in every option, okay, examiner given 2 grams weight. 2 grams weight. So simple, the first option I'm taking here, number of moles equal to weight by molecular weight. Molecular weight of copper is 63.5. This is number of moles. Okay, if I multiply with Na, Avogadro number, then I will get number of molecules. Okay, so this is number of molecules of first option, number of molecules. Second, B, 2 grams of calcium. How can you calculate number of molecules? 2 by 40, weight by molecular weight. This is the number of moles into Avogadro number of molecules. C, 2 grams CO2. Again, 2 grams weight by 40 gram per mole. This is number of moles into Avogadro number, so this is total number of molecules. D, 2 grams helium, 2 grams weight by molecular weight of helium, that is 4 gram per mole. Okay, so 1 by 2, that is 0.5 mole into Avogadro number, so 0.5 Na number of molecules here, 0.5 Na number of molecules here. Simple. Now compare everyone. You don't need to compare this numerator, so everywhere is 2. Now this is 63.5, this is 40, this is 40, and this is 44. Okay, this is 44 because CO2, this is 44, and this is 2. Here denominator is less. If denominator is less, then this value is high. Okay, if denominator is less, then this value is high. So this D, that is 2 grams of helium, has large number of molecules. So this has large number of molecules, so this has large number of atoms obviously. So answer is D. Understood or not? You have to calculate the number of molecules. Number of molecules equal to number of moles into Avogadro number. You have to calculate first of all number of moles. Number of moles weight by molecular weight, this is, and number of moles into Avogadro number. You will get number of molecules here. For every option you have to calculate like this. So here I have D, more number of molecules. Okay, so whenever I have more number of molecules, I will get more number of atoms too. Clear? Next question. How many moles of water present in 40 liter vessel at 600 Kelvin temperature and 1 atmospheric pressure? Simple. First of all, you have to identify here 600 Kelvin temperature and given water. I have already mentioned you in the last video that boiling point of water equal to 100 degrees Celsius, that is 373 Kelvin. But here 600 Kelvin. Whenever I have this temperature, then water is in the liquid form. But I have 600 Kelvin, very high temperature. When I have very high temperature, water behave as gas or a vapor, I can say. Okay, so this is gas. Now I have this volume, pressure, temperature. Obviously I have gas constant too. Gas constant 8.314 joule per Kelvin per mole, or 0.0821 liter atma per Kelvin per mole. This is my gas constant values. These are my gas constant values. Okay, now whenever I have this temperature, I can use this formula, number of moles. How many moles? They are asking, right? Number of moles equal to PV by RT. I can use this formula. Simple. Pressure, 1 atmospheric pressure into volume. What is the volume? 40 liters by 0.0821 liter atma per mole per Kelvin into temperature 600 Kelvin. Okay, Kelvin per Kelvin get cancelled. Atma, here 1 atmospheric pressure, right? So atma get cancelled. Liter get cancelled. Now have per mole in denominator. In numerator I'll get mole, right? So what is this value? 40 by 49.26. Okay, so that is equal to 4 by 5. I can write 40 by 49.26, 50. So I will get 4 by 5 So that is equal to 0.8 mole. 0.8 mole. Okay, this is very important question. Next, 4 liters of ammonia. 4 liters of ammonia gas at STP placed in a container. Calculate number of moles. How can you calculate this? Simple. 4 liters of ammonia gas at STP, standard temperature and pressure, placed in a container. So I'm taking one container here. In this, 4 liters of ammonia gas is there. Whenever I have one gas at STP, which formula you have to use to calculate number of moles? Number of moles equal to volume of gas at STP by 22.4. Okay, so what is the volume? 4 liters. 4 by 22.4 you have to calculate. What is the value? 0.1786 mole. Okay, so this value you will get. Next, very important question. The amount of C6H12O6 required to prepare 4 liter of its 0.4 molar aqueous solution is. Simple. I'm taking one container. Okay, in this container, examiner given concentration 0.4 moles per liter. Moles per liter. Here I have this C6H12O6. Okay, this is solution, 4 liter solution. Okay, aqueous solution. C6H12O6, this is solute. Now, what is the volume of the solution given? 4 liters. Now, asked to calculate mass of the solute. Mass of solute. Amount of solute is nothing but mass of solute. You have to calculate mass. How can you calculate? We have one formula, that is molarity equal to number of moles of solute. Number of moles of solute by volume of the solution in liters. Okay, I have concentration, I have volume, so I can calculate number of moles, right? So here 0.4 moles per liter into, I can write this volume of the solution, 4 liters. Liter per liter get cancelled. I will get 1.6 mole. Okay, I got 1.6 mole. Now, here I have 1 mole C6H12O6. What is the molecular weight of this? 180 gram per mole. 180 gram per mole. If 1 mole contains this much, then 1.6 mole contains 1.6 mole into 1.6 mole into 180 gram per mole. Gram per mole, mole get cancelled. Then my answer is 288 grams. Okay, this is the answer. These are the questions. Okay, I will come up with the new video. Thank you so much for watching. Take care. Bye bye.